Hey everyone, today we're going to have a look at simplifying surds and simple operations with surds. So recall from last lesson that a surd is a type of number that is irrational. And it's all to do with this idea of a root, so a square root and a cubed root or a fourth root and so on. And we said a surd was a number that when we typed it into our calculator, we got an ugly decimal. So the square root of 5 gives us 2.236 blah, 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 blah. And that's what we said a surd was. A square number was a number that when we typed it into our calculator, we got a whole number. So the idea of surds is working with what we call irrational numbers. Another famous irrational number is pi, another one is e, and another one is a famous one known as phi, which is the golden ratio. So recall that our square numbers are 1, 4, 9, 16, and so on. We're going to refer to these continually as we simplify surds. So let's have a go. We're just going to get straight into these examples of how to simplify surds. We have to look at our number and think, is there a square number that goes into 8, for example? And in fact, there is. We're going to say that this is the square root of 4 times the square root of 8, times by the square root of 2, sorry. And that's because 4 times 2 is 8, and since 4 is a square number, it's actually the square root of 4 is 2 times root 2. So the process of simplifying surds is going, is there a square number that goes into my surd? If so, how can I simplify it? So let's look at the list. The square root of 12, the smallest square number, or actually the largest square number we want, is going to be 4. And that's because this is the square root of 4 times the square root of 3. Because 4 times 3 is 12. So we're not just pulling these numbers out of nowhere. We have to think, what square number goes into 12? And that's 4. How do we know our square numbers? We continually refer to the list as we do these questions, so we can see 4 is a square number. So let's have a go at this next question here. So the square root of 4 is 2, and this is 2 times root 3, 2 root 3. Okay. Next question, we've got the square root of 32, and we want to have a go at simplifying that. We have to think what square number goes into 32. And it's going to be 16, so we're going to say this is 16 times by the square root of 2. That's because 16 times 2 is 32. Now the square root of 16 is 4, so it's 4 root 2. Okay. This next question here, we've got to ask ourselves again, what square number goes into 40? Now you might think, how do I know if a square number goes into it, especially if it's a large number like 90 or 160? Well, you're going to get out your calculator and type in 40, and you're going to start dividing it by random square numbers. We always are going to start at 4. So 40 divide 4. That works, looking pretty good. If I did 40 divided by 16, another square number, I get 2.5. So it doesn't go into 16 because 2.5 is not a whole number. But 40 divided by 4 gives me the square root of 4 times root 10. We're always trying to find a square number that goes into it. So I'm not going to say, well, I know that 8 times 5 is 40. There's no point of doing this because neither of those are square numbers, so it's not going to help us. So 4 times 10. Now the square root of 4 is 2, so this is 2 root 10. Let's think what goes into 90. I'm going to get at my calculator. 90 divided by 4. No, it doesn't work. So I'm going to try the next square number, 90 divided by 9. That works. So this is the square root of 9 times the square root of 10. Now the square root of 9 is 3, so 3 root 10. Last one, root 160. We've got to ask ourselves what square number goes into 160. We're going to try 4. Now 4 does work, but we want to always make sure we're trying the highest to the largest square number that will go into it. So let's try 16. That works. So this is the square root of 16 times the square root of 4. Sorry, the square root of 10, because 16 times 10 is 160. Now the square root of 16 is 4, so this is 4 root 10. Okay, Have a look at the addition and the subtraction of surds. Surds, when we add and subtract them, work exactly like algebra. So root 3 and root 3 are like terms. They're the same. So 2 root 3 plus 7 root 3 is 7, 8, 9 root 3. Now part B, here we've got root 3's and there we've got root 2's. If these were x's and y's, we couldn't add them. And in fact, root 3 and root 2 are not, we could say, like terms. They're not the same surd. So we can't add them. So this is really just a trick question. Okay, part C. We're going to think, okay, 7 root 3 is a like term with that one there. We can't add root 5's and root 3's, but I can add root 3's with root 3's. Now 7 minus 2 is 5. So this is 5 root 3. And then my other set of like terms are these ones. Now 3 minus 6 is minus 3. It works the exact same as algebra. So 5 root 3 minus 3 root 5. If you want to check that you're correct, you can actually type in the question into your calculator. It will give you a decimal. Type in your answer into your calculator, and it will give you the same decimal. If it gives you a different decimal, that means you're wrong. Okay, the multiplication of surds and the division of surds works a bit differently to adding them. All we have to do is multiply the number under the square root sign. So 5 times 2 is 10. Let's multiply the numbers under the square root time. 10 times 2 is 20. But this would not be accepted as a fully simplified correct answer. When we're working with surds, our answer must be fully simplified. And the square root of 20 can be simplified. And to simplify that, we have to ask ourselves, is there a square number that goes in 20? In fact, there is. It's the same as 4 times 5. And the square root of 4 is 2. So 2 root 5. When I'm multiplying surds with big numbers out the front, which there's technically a 1 here, I multiply them first. So 1 times 2 is 2. And root 5, well, 5 times 5 is 25. Now 25 is a square number. The square root of 25 is 5. So 2 times 5, which is 10. Question 4, we're multiplying the numbers outside the square root first. 3 times 2 is 6. And then 2 times 6 is 12. So 6 root 12. Now, root 12 is not acceptable. 6 root 12 is not acceptable as a final answer. And that is because the square root of 12 can be simplified. In fact, 12 is the same as 4 times 3. And funnily enough, 4 is a square number. That's why we chose it. We're not going to say the square root of 12 is 6 times 2, because neither 6 nor 2 are square numbers. Now the square root of 4 is 2, so that's 2 there. So this is 6 times 2 times root 3, and 6 times 2 is 12, and we're chucking a root 3 on the end. Again, if you're not sure whether you're correct, you can type the question into your calculator, it will give you a decimal, type the answer into your calculator, and it will give you the same answer. Right, number 5. Again, we're going to multiply the numbers outside the square root. 5 times 2 is 10. 6 times 3 is 18. Again, when we're doing these surds questions, we have to ask ourselves, is the square root of 18 fully simplified? In fact, it's not, because 9 goes into 18. So this is 10 times the square root of 9, and 9 times 2 is 18. Now, the square root of 9 is 3, and 10 times 3 is 30. So this is 30 root 2. That would be a fully simplified answer. Okay, the division of surds is almost the exact same as multiplication, except who would have thought we're dividing instead of timesing. Divide the numbers under the square root. 6 divided by 2 is root 3. 12 divided by 3 is 4, so root 4, but the square root of 4 is 2. 112 divided by 7 is 16, so root 16, but the square root of 16 is 4. The next thing is we encounter a bit of a problem here, because what we might think is, oh, I'm going to divide the numbers outside the square root first and then the numbers under the square root second. 2 divided by 7 is not a whole number, it's not an integer. So we're going to practice writing these as fractions, 2 root 98 on 7 root 8. And we're going to divide each of these individually. Now we can't divide 2 by 7, it's not possible. What we're going to do next is just divide 98 divided by 8. And on our calculator, it gives us 49 on 4. So we're going to express it like that. We're allowed to simplify that. That's because the square root of a on the square root of b is the same as the square root of a on b. So we can put our square root on the top or the bottom, or just express it as one big square root, and it means the same thing. So again, to get 49 on 4, I've typed into my calculator 98 on 8, and that gets me 49 on 4. Now the square root of 49 is 7, so 2 times 7, and the square root of 4 is 2. Type that into your calculator or just do some cancelling. You're going to get 1 as the answer. Okay, number 9. Let's again express it as a fraction, 4 root 27 on 2 root 12. Now 4 on 2 is 2, and root 27 on 12, so 27 on 12 on my calculator, gives me 9 on 4. So I'm going to write it as 9 over 4, like that. And really there's a 1 there, so 4 on 2 is the same as the fraction 2 over 1, and 27 on 12 is 9 on 4. Now the square root of 9 is 3, so this is 2 times 3. The square root of 4 is 2, and that's 3. Type it into your calculator, or 6 divided by 2. Example number 10, we're going to write it as a fraction 3 root 8 over 2 root 20. Now we can't simplify 3 on 2, so let's leave it as 3 on 2. But we are going to type in 8 on 20 into our calculator, and it gives us root 2 on root 5. Now neither of those are square numbers, so that's actually our final answer there, 3 root 2 on 2 root 5. Later on in year 10, we actually can learn how to simplify that a bit further by doing something called rationalizing the denominator, but at the moment this is an acceptable answer. So again, to get what we just did, to get 2 on 5, we go 8 on 20 gives us 2 on 5, but we've got those square roots still hanging around. Okay, example number 3. This is just expanding brackets. So we are just going 4 root 3 times root 12 minus 5 times 4 root 3. Now when we multiply surds, we multiply the big numbers and then the numbers under the square root. 3 times 12. Now 3 times 12 is 36. Minus, we multiply the big numbers first. 5 times 4 is 20, root 3. Now the square root of 36 is 6, so this is 4 times 6 minus 20 root 3. And 4 times 6 is 24, so 24 minus 20 root 3. Okay, thanks for listening.